Hey there! In my last Java programming video, I talked about making everything private to start when designing classes, especially attributes. It's a contentious point lately. I've seen a few articles against this circling the internet, and I've even been asked about it. So, it seems like a good topic to dive deeper into. In this video, I want to dive more into why private scope should be your default starting point when designing classes. We'll talk about what it means in general for methods, and then we'll talk about the contentious point, getters and setters. If we start out with everything private, there isn't much to do with the class. There's little you can do to mess it up, too. It's just kind of useless. Once you expose a method or attribute publicly, you've provided one new way another class can change your class. This leads to something called the principle of least privilege. It's usually applied to security, but it also works with encapsulation. The idea is we want to expose an API for another class to perform the task it needs to, and nothing more. A simpler API means it's easier to understand, it manages complexity in our application, and it's much easier to test. In this example, the only API exposed to other classes is move spaceship. The checks and action are all internal workings of the class. The other classes don't need to know how that happens. They just need to tell the spaceship to move. Starting with everything private makes a much smaller exposed API for our class, which is easier to understand. There's nothing to call. Add one call, and another class can make, and it's very easy to understand how to use our class. We make that one call. That's important because other classes do not need to know how our class works. They just need to know how to use it. Fewer public calls make it easier to understand. A simple API helps manage complexity. Imagine we have a class that's called from other classes. If we have one public method, that's one way each class can interact with our class. That's pretty simple to understand. Now imagine there's 100 ways to our class. That makes a very complex system, and it's not easy to see how things work. We want to manage complexity because it makes our system easier to test. Each line in the diagram is one interaction that requires testing. Everything private can be tested in a unit test. Failures between classes can only happen where the classes touch. So, let's talk about getters and setters. They're not popular because it looks a lot like boilerplate code. It's simpler to make the attribute public, so why is that bad? Well, a public attribute makes the value and behavior of changing the value the same thing. That violates encapsulation. We cannot apply any rules for how the values are modified. The value gets modified and there's nothing we can do about it. Our object can be placed in an invalid state. Using getters and setters allows us to separate the behavior of changing the value and the value. We can make our setter private, and now we have a read-only value. Or we can use our setter to perform validation or other operations on the value before modifying the class state. If our rock can only be at positive positions, we can make sure the value is greater than 0 before setting it. A getter allows us to separate when a class state is returned. For example, if it takes a long time to calculate the attribute, we can lazily load the attribute. Calculate the value when we need it. From the calling class, we just get the value. In this case, what occurs in the process of getting x is hidden. The calling class doesn't need to know about calculating x. And it means our API has only one meaning for the getter: get the value. That's a simple API, and the ability to set the value isn't exposed at the same time like it is with a public attribute. So your next thought is probably, well, it's like make our attribute immutable. That means the attribute is marked final. If our immutable reference points to a mutable class, exposing it directly means that anyone can change the values. They just can't change the reference to a new class. At that point, we might as well make the attribute mutable, because immutability is not helping us. Making the attribute immutable helps for private attributes, but we're still locked to our API. We can't make internal changes to our class without changing the API. If we later need to perform validation on attribute 1, we have to change how it's set and retrieved. That means any change to the public attribute will have downstream effects to every class that uses our class. What about package scope classes? Well, that's probably the only place we could even consider making attributes public. The package scope of a class will limit what classes can change the attributes, and if we need to change the API, the number of downstream classes affected will be very few. The only thing we'll gain really is more succinct code, but that's a plus, and the downside of a changed API is manageable. It's all about controlling how our class is used, and more importantly, how its state is changed. Public attributes allow type safety, and that's it. There's no other protection. So, hopefully we're on the same page about public versus private attributes. If not, let me know in the comments. Hey, thanks for watching the video. If you like what you're seeing or have any questions, let me know in the comments or on dgu.com. New videos come out every week, so make sure you subscribe. You don't want to miss a video. In fact, let's go watch another DG video. See you there.